Hello, my dear students. How are you all? I am fine. I am Khandekar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. Dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important creative question from chemistry first paper, chapter 4, chemical change. My dear students, here given our first stem. In first one, phosphorus pentachloride reacts and produce phosphorus trichloride and chlorine. This is gas, this is also gas, and this is also gaseous state. LH value of this reaction is positive, and 15% of the reactant, that is phosphorus pentachloride, is dissociated at 30 degrees Celsius temperature and 1.5 atmosphere pressure. And our second reaction is at 500 degrees Celsius temperature and 50 atmosphere pressure. 25% AB3 is formed from the reaction of two gases A2 and B2. Dear students, our first question: determine the Kp of the reaction 2 in the stem if degree of dissociation of A2 is alpha. Our second question: determine the value of Kp of the reaction 2. And our third question: show with the help of a diagram the change of Kp with the increase of temperature for the reaction 1. My dear students, now we discuss about the solution of these three questions. My dear students, our first question was determine the Kp of reaction 2. According to our stem, our reaction 2 is A2 plus 3B2 reacts and it produces 2AB3. My dear students, at initial stage, my dear students, let A2 is 1 mole, B2 is 3 mole, and at initial stage product is 0. But at equilibrium, here given the degree of dissociation is alpha, so here we get 1 minus alpha, here 3 into 1 minus alpha, and product is 2 alpha. My dear students, now to calculate the Kp, at first we have to calculate the total mole number at equilibrium. That means at equilibrium, total mole number equal to 1 minus alpha plus 3 into 1 minus alpha plus 2 alpha, and we get 4 minus 2 alpha. And now let total pressure equal to P. So, my dear students, now we can calculate the partial pressure of A2 B2 and AB3. So partial pressure of A2, that is PA2, equal to mole fraction of A2 into total pressure. So mole fraction of A2 equal to 1 minus alpha divided by 4 minus 2 alpha and total pressure P. So partial pressure of B2, that is PB2, equal to mole fraction of B2, that means 3 into 1 minus alpha divided by 4 minus 2 alpha into P, and partial pressure of AB3, that is PAB3, equal to mole number of AB3, that is 2 alpha divided by total mole number 4 minus 2 alpha into P. So this is the partial pressure of A2, partial pressure of B2 and partial pressure of AB3. Now, my dear students, according to mass action law, Kp equal to partial pressure of product divided by partial pressure of reactant. That means PAB3 mole number will be the power divided by PA2 into PB2 cube. Here this mole number will be the power. Now the value of PAB3 is 2 alpha divided by 4 minus 2 alpha into P whole square divided by 1 minus alpha 4 minus 2 alpha into P. This is the partial pressure of A2, and partial pressure of B2 is 3 into 1 minus alpha 4 minus 2 alpha into P whole cube. Now we get 4 alpha square P square divided by 4 minus 2 alpha whole square divided here P3 cube, that means 27 P cube into P, that means P to the power 4, and 1 minus alpha, you can here 1 minus alpha whole cube, that means 1 minus alpha whole to the power 4, and 4 minus 2 alpha into 4 minus 2 alpha cube, that means 4 minus 2 alpha whole to the power 4. Now my dear students, here we get 4 alpha square P square divided by 4 minus 2 alpha whole square into 4 minus 2 alpha whole to the power 4 divided by 27 P to the power 4 1 minus alpha whole to the power 4. Now we get 4 alpha square into 4 minus 2 alpha whole square divided by, this is 27 P square 1 minus alpha whole to the power 4. Here 2 is common, so 4 alpha square to 2 minus alpha whole square divided by 27 P square 1 minus alpha whole to the power 4. And now my dear students, we get 2 square equal to 4, and 4 into 4 16 alpha square 16 alpha square 2 minus alpha whole square divided by 27p square 1 minus alpha whole to the power 4. My dear students, this is the Kp equation for this reaction. My dear students, our next question is calculate the Kp value of reaction 2, and according to reaction 2, the reaction is A2 plus 3B2 and product is 2AB3. My dear students, according to the STAM, we know that at equilibrium the amount of AB3 is 25%. So let total mole number at equilibrium equal to 100 mole. So mole number of AB3 equal to 25 and mole number of A2 and B2 equal to 100 minus 25, that is 75. My dear students, here we see that the reactant A2 and B2, that means the ratio of A2 and B2 is 1:3. So mole number of A2 is 1 divided by 4 into 75, that is 18.75 mole. Mole number of B2 equal to 3 by 4 into 75, that is 56.25 mole. My dear students, now partial pressure of A2, that means what is partial pressure? Partial pressure equal to mole fraction into total pressure, that means partial pressure of A2, that is PA2 equal to mole fraction of A2 into total pressure, that means mole number of A2, that is 18.75 divided by total mole number 100 into 50, because according to the STAM the total pressure is 50, and we get the answer is 9.37 atmosphere. And partial pressure of B2, that is PB2 equal to mole number of B2, that is 56.25 divided by total mole number 100 into total pressure 50, and we get the answer is 28.125 atmosphere. And partial pressure of AB3, that means PAB3 equal to mole number of AB3 divided by total mole number of the reactant and product, that is 25 divided by 100 into 50, and the answer is 12.5 atmosphere. So we get the partial pressure of this reactant and product. Now according to mass action law, Kp equal to partial pressure of product divided by partial pressure of reactant, that means PaB3, and mole number will be the power, Pa2 into Pb3. These are the product, partial pressure of product, and mole number will be the power. And now my dear students, the value of AB3, PAB3 equal to 12.5, that is whole square, divided by partial pressure of A2, that is 9.37, and partial pressure of B2, that is 28.125 whole cube. My dear students, now we get the answer is 7.491 into 10 to the power minus 4 atmosphere inverse 2. This is the Kp value of reaction 2, my dear students. My dear students, our next question is show with the help of a diagram the change of Kp with the increase of temperature for reaction 1. Dear students, here this is our first reaction. Phosphorus pentachloride produce phosphorus trichloride and chlorine, and the value of del H of this reaction is positive. That means this is endothermic reaction, my dear students. This reaction is an endothermic reaction. We know that temperature has effects on equilibrium constant for a reversible reaction at equilibrium. Due to the temperature increases or decreases, equilibrium constant changes like the equilibrium. The Bandt equation to explain the effect of temperature and equilibrium constant, my dear students. Here this is the Bandt equation, log Kp equal to minus del H divided by 2.303 R into 1 by T plus constant. Here del H is the same change of enthalpy, T absolute temperature, and R universal gas constant, my dear students. My dear students, this equation is like a equation of a straight line, that is y equal to mx plus c type equation. Plotting the value of log Kp y-axis against the 1 by T value in x-axis will give a straight line. For endothermic reaction, 1 by T increases, that means T decreases, and the value of log Kp decreases. So thus the value of equilibrium constant will be increases if the temperature increases, my dear students.